Hi, I'm John, and welcome back to my garden scale Climax project. Last time, we evaluated the mechanical aspects of the model and installed the speaker. The next step in the process of converting this locomotive to battery power is to install the battery, associated electrical components, and the Blunami decoder. This is a great time to thank SoundTraxx for providing the decoder for this project. I'm confident that the Blunami will provide great sound and control, and to make things even better, SoundTraxx decoders are made right here in the US. You can find a video tour of their facility on this channel by searching for it, or just find the link in the description to see how the SoundTraxx decoders are made. Speaking of links, I also have included affiliate links in this video's description so you have access to the same kind of tools and supplies that are being used in this series. So let's head over to the workbench and get on with the electrical and electronics installation process.
Hi, welcome back. My name is Trevor Park from the Fern Creek and Western Garden Railroad, and today we're going to continue working on John's Climax locomotive model. We've prepared the locomotive in the last video for our new battery system and Blunami decoder we're putting in it. It's all wired up, ready for install, so now we're going to dive right back into the locomotive and start putting all the stuff in it. So at this point, we're going to take the tender off to access the area where we've wired everything for the decoder, because the next step at this point is actually putting all of the electronics in the locomotive. So once again, it's just these two screws. They're in these water hatch cover, the water shutoff covers actually that are on the tender here. And once those are off, the tabs will release on the rear. The tender should just come right off. So last time we rubber banded everything together just to get into the tender. So now we'll take that off, and that will expose all the loose ends of the wires. We will have to do a little bit of stripping of the wires in order to get them ready to put into the decoder, because the decoder has screw terminals on it. So before we actually put the decoder in, we'll strip all the wires, cut them roughly to length so it's a little more organized, and also tin the ends where we put a little bit of solder on them so that they are able to attach to the decoder more securely. The colors of the wires aren't exactly correct for NMRA standard color coding, simply because I just didn't have enough of the color-coded wires, and the way that Bachmann originally wired this engine was not color-coded at all. It was just all black and red wires, so you really couldn't tell where things were going. I have put some color-coded wires on here, especially in areas where I needed to extend the wires, but before I put it back together last time, I actually took somewhat detailed notes of what each wire meant, especially because there's a few black wires that look very similar. But as we put it together, I will explain what the wires are, and you'll see, I got a couple black wires like this one. This is actually the headlight, and then these two that are unstripped at the end are actually the speaker, which was how I was able to tell them apart. As long as you know your own color coding system and know what everything is, it's fine. So now at this point, we're going to kind of roughly place the decoder in and figure out what lengths we need to cut all the wires to, so we have a nice clean wiring job and we're all done, and then we'll start stripping and tinning the ends so that we can put them in the decoder. So I've placed the battery and the decoder roughly where they're going to go in the tender, just so that we know exactly the length the wires need to be. I mean, you could just put the decoder in there, but remember it has to lift up about, an inch and a quarter or so in order to get up over the battery. So this is the best way to plan your install, is to have everything in there that's large, that can't be easily moved around, so that you can have the wires as close to the right length as possible, make sure everything fits correctly. So as I mentioned last time, the decoder we're using for this project is a SoundTraxx Blunami decoder. It's their Blue 4408 decoder, which is a 4-amp decoder meant for large-scale locomotives. And the really cool thing about this is that we're actually going to be able, at the end of this project, to run the locomotive off of their app that can be installed on a smartphone and use that as the controller, and run it off the battery power, so it'll be completely dead rail on the garden railroad and totally controlled through the phone. And we've never used one of these before. It's my first time installing this particular decoder, and it's going to be really cool to see it in action. So before I do any decoder install with a new decoder, I actually look at the instruction manual first, and I read through it, It's fairly similar to their Blunami decoders. There's a few variations. There's a few more function outputs. And so now that I know what everything is, and it's actually clearly labeled on the decoder as well, we are going to first stick the decoder down to the battery with a piece of double-sided foam tape. And this will help us make it a lot more secure. So after doing some planning and figuring out exactly how I want the install to look in the end, I decided to turn the battery around so that the wires are coming out in a better location for the fuse and the switch and everything that's eventually going to go in. And so now we're going to stick the decoder down with a piece of double-sided foam tape. This not only provides a nice pad for the decoder to sit on, but it also makes it so that it doesn't rock around while we're trying to connect all the wires in it, so we can get a fairly precise length on all the wires we put onto this decoder. So we just peel the backing off, find as close to center as we possibly can, and then stick it down and press very gently on it, and voila, they're now together. The next step is to start cutting and tinning the wires. So we're going to cut them to length, and then we're going to do a process called tinning, where we take the bare end of the wire, put a little bit of flux on it, and then just lightly touch the soldering iron with a little solder on it. This firms up the end of the wire, makes it nice and hard so that when you put it in there, it doesn't flop around. So we're going to roughly find the length of the wire we want. We want a little bit of excess, so there's a minor loop coming off it. You don't want to have it super tight because it would risk pulling out, but you just want it roughly close, about like there. So we'll cut it like that, and then using a wire stripper like this one, we'll find the correct size wire. I believe this is a 22 gauge wire, but we'll find out here in a moment. There we go. So now we got a bare end of the wire, and before I touch the soldering iron to it, I like to twist the end just very lightly so that the ends don't fray out when we try to tin it. So now we'll take our flux, which basically acts as an agent for the solder to actually flow onto the wire and not beat up on it, and we'll just dip the wire in a tiny little bit of flux. It doesn't take much. And now we'll take our soldering iron, just a little dab of solder on it. Now we will just touch that to the wire, and you'll see it change color to that nice silver color, and it is ready to go in. So now with the wire tinned, this is the positive motor lead for the front truck. So we will take that and insert it into the screw terminal. And then once you get in there, you just tighten down the screw, give it a little tug, and the wire's secure. So now we're going to repeat this process on all of the wires that you see here, tinning them and stripping them so that they can get into the screw terminals, cutting them to length. So now that I've shown how to actually use the screw terminals and properly tin the wires, I'm putting all the wires into the decoder. And something that's important to mention is there are a few terminals where there's actually two wires going into them, particularly for the leads to the motors, because this engine actually has two motors, one in each truck. So for those, I actually generally tin them together, so they're soldered together, and then put them in because there's less risk of one pulling out and the other staying in. The other thing that I'm doing is you'll notice I'm lengthening a couple of the wires. It turns out that the wires that go to the speaker we put in the firebox are actually slightly too short. And this is something that occasionally happens. You know, I didn't plan correctly and the wires were a little too short, but it's easy enough to just add a little extra wire on the end and then use a piece of heat shrink tubing over the wire to cover up that joint, and then repeat the same process we did for putting in the screw terminal. Now at this point we've hooked up everything on the decoder, motor leads and all that, except the lighting functions. And the reason that I held off on that was to show everyone the fact that you need to use resistors on the lighting functions, because everything on this engine is an LED, except the cab light. We will not be using a resistor on that because that actually is still an incandescent. But everything else will use resistors. The resistors I'm using are these right here. These are quarter watt 2000 ohm resistors, and I'm using a slightly higher ohm resistance than you would for, say, like an HO scale locomotive, because you're getting a full 14.8 volts, almost 15 volts of power out of this battery when it's going to the decoder. So you want to use slightly higher resistance. And I put these on each function lead to each lighting output, not on the common lead. The common lead, which is this blue wire here, goes to all the lights, but you want to use a separate resistor on each one so that they all have their own full resistance and they aren't using up each other's resistance. So we're going to put these on, and basically the way we will do this is we will actually plug the resistor into the screw terminals, and then we will solder the correct function wire to the end of the resistor, and we'll cut it down to length, and then we'll put a piece of heat shrink tubing over the whole thing so that it covers it up and makes sure that there's a nice insulated connection where it comes into the board. So we have everything hooked up to the decoder. The final task with wiring really is to hook up all the stuff that's associated with the battery system, because we haven't done any of that yet. So what we'll be installing is a fuse holder with a fuse that'll be put in it, and it's a 5 amp fuse, so if something goes wrong, the battery surges, it'll protect the decoder from a surge and blow the fuse. We're also going to put in a charging jack that'll allow us to charge the battery without having to, take anything off the locomotive or that sort of thing. And of course, an on-off switch that will allow us to turn the power on and off on the locomotive. So we're going to put all of this in, and not only the wiring portion, but also screwing these things into the locomotive so that they're secured and drilling out holes in the engine for them. Thankfully, we actually already have some holes that were made by the previous owner, and we will reuse at least one of those and then drill a new one for the charging jack. So before we do the rest of the work to install the battery associated equipment, you'll notice I've actually turned everything on its side. And the reason for this is to actually accommodate the charging jack, because after we had gotten everything put in place, I realized that the charging jack, which we plan to mount up in the water hatch, which is right here, is going to stick down a good ways. And I don't want it to contact the decoder accidentally, because I think it will actually contact the decoder where it was. So I've turned everything on its side, we've test fitted the tender, and it actually fits way better this way. So thankfully, the nice thing about having a little bit of extra length in the wires is you can do something like this where you turn it over and reposition things a little bit. And you can see actually it cleans up the wiring job pretty nicely. So this is the way we're going to have it now, with the decoder on its side, mounted towards the front, battery, and then the tender will sit on top. So before I do all of the really fiddly wiring in this tight space, I just want to show how I have this planned out. That is the switch, the on-off switch right there going through the floor, so you'll be able to just reach under the locomotive and toggle the switch on and off. And then I have the fuse holder right there, and that'll have a fuse plugged into it, and the cap there goes over that, and then the wires will go to the decoder, but first through the switch so that we can actually turn it on and off. So basically how it'll look is you'll have power coming out of the battery on the positive lead, going into the fuse so that everything is fuse protected. Then it'll go to the switch. There'll be a branch off the switch to the charging jack and a branch off the switch to the decoder. And then the negative will also plug into the charging jack as well as the decoder. So that's how it'll look when it's all done. It'll be a little hard to see because it'll be some fairly tight, fiddly work to get it all to fit, but that's what it'll look like in the end. We'll show a little bit of it as I do it and then come back and show the finished product of it all together before we test the locomotive. So despite how small and cramped this area is, I managed to get everything wired up. All the small scale people are going to be like, that's not cramped. But in any case, it's all wired up now, and you can refer back to the diagram we showed a little bit earlier in the video to see what exactly all this looks like in a more exploded view. But we have it all in. The fuse holder is attached with a fuse in it. The switch is bolted into the frame, and that's just a nut that threads onto the switch, just like any switch that is mounted to a circuit board or anything like that. And it's up under the locomotive so you can turn the engine on and off. The final thing we have to do is I've already wired the charging jack in, but we actually need to secure the charging jack onto the engine. And on this particular switch here, we already had a hole in place, which was really nice to mount it in. But for the charging jack, we're going to need to enlarge a hole that is in the water hatch on the tender. And that makes it really nice for putting this in on the tender, because then you can just plug in right on the top of the locomotive and not have to fuss with turning the engine over or anything like that. So there's already a hole in the water hatch on the locomotive, but it's not quite large enough to fit the charging jack in it. So we're enlarging it using a 5/16 inch drill bit, which should be just about the right size. So just line it up with the hole and start drilling. We have the hole enlarged, and so now the charging jack fits in just beautifully, like that. And so now we'll turn it over, and now you can see the charging jack is right there in that water hatch, so that when we come in with the male end of the jack, we'll just be able to plug it right into the hatch, into the top of the engine, and charge the battery. So now I'm going to use the supplied nut to tighten down on it, and it's going to be a bit fiddly because I have to get in there with the long needle nose pliers and thread it on. So I'm not going to be able to show that on camera, but we'll come back with it all secured. We'll put the tender back on the locomotive, and then we'll test it. All right, so the charging jack is installed securely in the top of the water hatch. And so now the final step is we just need to make sure the battery is secured down, and all that requires is just a little piece of double-sided stick tape on there. So since this is going to be kind of a tight area, we're going to take the backing off first and then just stick it up on the tender. And then make sure that the thing goes down in the correct place and give her a nice little press down. And like that, we should be ready to reassemble. So put the tender back on, and hopefully everything goes back on. There you go. So now we'll screw it all back together, and then we'll give her a little test. Okay, so the tender is all back on, the engine is all back together, and now it's the moment of truth. So it powers up. It didn't blow up. That's a good start. No fire. No, we haven't released the blue smoke out of it. So now the Blunami app is connecting to the locomotive. This is actually my first time using the Blunami app. And when it whistles, apparently it's connected. There we go. Okay, so let's just quickly test. We have a headlight, that's good. And we have a backup light. And we can ring the bell, blow the whistle. And I guess we'll try moving it then. So I see a little bit of hesitation in the engine set, which probably means that we got a bad gear somewhere, which is pretty, typical for these sorts of locomotives. Yeah, it's really not happy with that. Yeah, so we're going to stop that before we cause more damage. But good news is the motors are working, everything's running in the right direction, the lights are working, the sound's working. Bad news is that, there's a bad gear. And what I suspect it is it's the gear that actually drives off of the motor in the truck there to the engine set here. Because you can see the motors and the trucks are all running fine, it's just the engine set's binding up. So in a future video, we'll likely address some of the mechanical issues and cosmetic issues with this locomotive, and that'll be the time that we fix it so that we can run it on the Fern Creek and Western or wherever else John wants to take it, and it can run reliably. But the good news is that everything we did wiring-wise and electrically all works, and the engine, in that regard, is ready for service. Well, despite the fact that the model didn't work exactly as we wanted, because nothing ever goes according to plan, I'm overall very happy with the way the install turned out. Electrically, the engine is sound, it runs, and it was a really unique opportunity to finally get to use one of the Blunami decoders, and I'm very impressed with how the system worked on the phone and everything. I'm really looking forward to diving into that a little more. So thankfully, we have a donor locomotive lined up that we're going in on to make sure we have enough parts to complete this locomotive. And in theory, that engine should have the parts we need to make the engine set work correctly. Because really, that's the only problem. The engine set's driven off of the gears in the trucks, and it's binding. And once we have that correct gear to go in there to replace the stripped gear, we should be able to have this engine running just fine. These older Climax models were released over 20 years ago by Bachmann, and they were notorious for gear issues that they corrected in a later version of this locomotive. And so it's just part of the problem with these engines that has to be dealt with, and it's something we will deal with and come back, make the engine cosmetically look better and mechanically work better so that she's ready for years of continued service in the future.
So, now we've installed the speaker, battery, and decoder in the model, but we also uncovered an issue with the propulsion system. This kind of thing seems to happen a lot with older models. The more you dig in, the more problems you find. You can join us in the next episode to see how we improve the looks and troubleshoot the drive mechanism issue that we uncovered in our test run today. Be sure to subscribe to this channel and tell your friends about the interesting things you're discovering. Thanks, and we'll see you next time.